So as you all know, TED is about ideas worth spreading. And your theme is a very interesting one, omnipresent inspiration around us. And with my profile that she has just said, to me, what is all around us is quantum. And I want you to be informed about quantum readiness. So that is the theme of what I want to talk about. And there are many takeoff points. You see, some of you who have an idea or have looked at literature would have seen that there's a very famous thing where in one of Moliere's play, the protagonist was very surprised that he speaks prose all his time. So actually he wanted to learn poetry to be able to impress some friend of his, and the person was telling him, his mentor said, there is poetry and there is prose, and what you speak is prose. So I've been speaking prose all my life. You have been experiencing quantum all your life, and you will continue to experience quantum, and I'm trying to do a little bit about getting you further prepared to really appreciate that quantum world. I come from a physics background, and one of my mentors, of course, I read his book earlier, met him in person much later, John Simon, has a book called Principles of the Theory of Solids. This is a book about solid-state physics, which was, kind of not exactly quoting, but paraphrasing from his 1964 edition, because it has got several editions. And it says that the frontiers of knowledge are always on the move. The research that is done, and the latest research, becomes the mental furniture of the researchers. Very soon, it is expected to be part of graduate lectures of all good universities. In a couple of years, there is a clamor that it should be in the undergraduate curriculum, and in a short time, it will be seen that every schoolboy knows it. This he said in 1964, but today, in 2022, it is actually real. You'll be surprised how much your students know about what's happening which has not been taught to them. And quantum is one of them. And why quantum is very important and interesting is that it is the fundamental theory of how the world works. And it is not only in physics, it is also with respect to biology, chemistry, every other field at its fundamental level becomes quantum. You've heard of the virus and the virus mutations that are happening. And you've heard this, everybody knows, and alpha, beta, gamma, omicron, and we don't know, BA2, etc. But this mutation is not just a random thing. It may appear random to us because we don't know, but actually all such genetic mutations are some transport between the atoms, the hydrogen atoms, and how they're arranged and so on. And there's a very famous biophysicist who's, of course, got the Nobel Prize for discovering vitamin C. He said that it is not these molecules which are the real thing. They are just the stage, but the players are the electrons and protons. And what are they talking about? They're playing a script called quantum. I'm not using the word mechanics or physics or science because it's a matter of description. There's another reason why it is very interesting, because India has made significant contributions to this field, although we don't see this on a day-to-day basis. So C.V. Raman, in fact, we celebrate Science Day on, I think, February 28th or so, which is his birthday, got the Nobel Prize for what is called the Raman effect, which was basically a quantum phenomenon, and 1930 or so. Somebody who's unfortunately not been so well acknowledged was Satyen Bose, and half the particles of the universe are called bosons in his honor. But he unfortunately didn't get the Nobel Prize. We won't go into that. But Higgs boson, which was a big story a few years ago, they got a Nobel Prize for discovery, for theory, etc., etc. And among youngsters, there's a person called Love Grover, who is very famous for one of the two quantum algorithms today. The first algorithm, which was done earlier, was by Peter Shor. It was this thing. And then Lovegrover, he created a quantum algorithm for searching large databases. Because as you will see, quantum computing becomes very powerful because it gives you lots of. But I'll go to Peter Shor also. So what Peter Shor did is something very interesting and has huge implications for everything. So you have now seen that we are talking about digital, crypto. All of you are aware that when you have things, they are encrypted, decrypted, and that's how you get security, and etc. But how do we encrypt and decrypt? And this is something which is from times immemorial. One of the earliest ways of crypting was what was called the Caesar shift. So you just change one letter, and so if you are writing A, you say instead of A, I will write something else. Instead of B, I will write something else. Instead of C, I will write something else. So you create a code, and so this was a very, very well-known method. In fact, the Second World War, the Germans actually lost because their code was decrypted by computers of the British side at Bletchley and so on and so forth. Now, there are ways of beating it. So if you take the normal English language and you're sending messages in the English language, E is the most frequently occurring letter. You know that Q is very rarely occurring. Q always occurs with U. So if you're doing a simple shift, by analysis with the computer, you can figure out what is what and so on and so forth, and then you say what makes meaning. But today's security, the one you have on all your electronic systems on which the whole quote-unquote world is running, is based on something very interesting, very simple. It is based on what in mathematics are called one-way functions, or in life you can call them one-way operations, which means you can do that thing, but you can't undo it. Now, you know, for example, very often we say you can add sugar to water or milk, but then once it is dissolved, you cannot take it out. This happens in so many places, but I will give you a simple example of school arithmetic. Multiplying two numbers is fairly easy. Even if they are very large numbers, you just operate on one number at a time. If you can carry over, you can multiply two very large digit numbers with nothing more than your pencil and paper. But the inverse of this is very difficult. If I give you a large number and say factorize this number, then you can't do it easily, especially if the factors are prime numbers. So one of the things that happened in the history of computing which led to this was three people, RSA, So what they did was they took one 64-digit prime number, one 65-digit prime number, multiplied them and opened it to the world. And say, here is now a 129-digit number, can you factorize this? And obviously, internet, collaboration, etc., they were able to do it, and this is called the RSA algorithm for cryptography. So you take original data, do something with this thing, and then it is not easy for anybody to decrypt unless he or his machines can factorize this, and this was there. Now, of course, we use something RSA 20, 25, whatever, which is a very large number, and therefore you can put all computers together, but in reasonable time you will not be able to crack it. But Peter Shor's algorithm says that it can do that. It can factorize any large number using quote-unquote quantum algorithm attributed to Peter Shor. And the day it is done, all your information security is gone. All your crypto is gone, all your blockchain is gone, everything is gone. The only thing is such a quantum computer does not really exist. The method exists, but the tool doesn't exist. But I just want to tell you why this is important to start appreciating this kind of thing. Now, you may feel that, but what the hell is quantum? And for people of our generation, it was somewhat difficult to visualize this because it was not easy. You could never see things in such granular stage. At the most, we had a microscope in a laboratory in which we could see something small. But today's children, and of course grown-ups, we see all these images. And we know that these images are pixels. And when you do a thing where you get what is called pixelation, you can see the pixels but not the full image. But when you see there are a large number of pixels in a small area, you see a continuous image and it looks like this is a real thing. So 4K, 8K, whatever you like to do. This is what quantum is. Quantum is the smallest unit in which nature exists. When we see larger aggregates of that, of millions and trillions of them, then we see them as continuous objects that we go. But if we could go deeper and deeper, then the next question comes, quantum of what? The pixel is, as you know, eventually a matter of size. So you can say so many millimeter by so many millimeter, or fractions of millimeters of whatever. Quantum is the smallest unit of something else which is called action. And I'm saying this because it is good to really know what things are about. And action is a little complex term in physics which talks about motion. And the unit is energy times second. Erg second is the unit. Now, so everywhere where there is movement happening, whether it is your drugs going through your bloodstream or your electrons and protons going through this thing, or you have the Hodgkin-Huxley equation, or you have photosynthesis, or you are smelling. Do you know that a sense of smell is because of the quantum phenomena? And this is where the whole thing becomes so interesting. And when we want to get into explanations, now the point is, until you know it, it is a mystery. But there is nothing which cannot be done to demystify it. So I began with defense, I began with this, etc., and so on and so forth. The things that you are having on your hand, the phone that you have, the computers that you have, etc., they're all based on quantum phenomena. But not at the real quantum level. These things happen, but for your purposes, it is something which is a device which does something and so on. But what is going on in the device, and many of you will get to know if you are going to be into computers, electronics, etc., is all because of the movements of the electrons, especially the behavior of the charges of the electrons, and the field is called electronics. So you've seen electronics has been on for a long time. Now what people are doing is they're going beyond the charge to another feature of the electron called the spin, which is a magnetic moment or an intrinsic magnetic feature of the spin. And therefore we are getting a whole new field called spintronics. Some of you may have had opportunity to know of someone who had to undertake an MRI. Now, X-ray was one kind of a thing which was high frequency radiation, but were electromagnetic waves which could go and get you pictures of the bones inside you. But X-rays couldn't do more than that. Ultrasound could do a little more than that. But MRI goes into the brain and can almost see which part of the brain is functioning, active, and so on. That's why they use fMRI techniques to understand neuroscience and so on. It is basically based on the fact that we are a large amount of water. Water is H2O. H2O is hydrogen. H is hydrogen. Hydrogen has something called the proton, and the spin of that. And that's why it is called magnetic resonance imaging, because what magnetic field you apply gets that proton to resonate according to something, and that can give us images of what is happening. This is the kind of thing. Now with quantum level further, this MRI machine will start beginning to look like a torch. And you will have something very small, the field of diagnostics changes, you can see what is under the earth. We have no way of knowing what is 10 feet below our thing, but quantum sensors will allow that. So towards conclusion, thousands of years ago, humans domesticated wild animals and were able to use their power. So we domesticated the wolf, it became your pet dog. We domesticated horses, they became horses on which you rode and all over and got that kind of energy. In fact, motors are often referred to as horsepower and so on and so forth. And we domesticated animals and other kind of things. Now for the last 50 to 100 years, we have been domesticating the electrons and protons and these atomic particles. You know, the first domestication of the atom was the nuclear explosion, the atomic bomb, the hydrogen bomb, and so on. Now, you also know, and this is common knowledge, that it is that hydrogen bomb thing called fusion which gives huge amount of energy, and many of you probably know that the sun runs on fusion energy. But that happens because of quantum tunneling of something between that. So the sun's origin of energy is quantum tunneling. The photosynthesis that happens is quantum. And we are finding more and more in the last few years, and in fact, there are now huge groups all over the world. See, you remember that what happened, science typically is pursued for curiosity. So whenever all these people discovered X-rays, etc., they had no goal mission that I have to find X-ray. They were doing something and X-rays appeared. Much of science is something where people stumbled upon. Right from Archimedes in his bathtub, he stumbled upon Archimedes' principle. Now what has happened is, after this thing, we have started having projects. So the Manhattan Project was about atom bomb, fusion energy, electron fission energy. Then we had the space mission, we had this AI kind of a thing which was going around. And now finally we have the quantum mission. And if you're following the news, China is leading very aggressively. All of Europe is leading very aggressively. US is worried that they might be losing their technical advantage. After the war, US was the most important technical power. But they are feeling very, because China is working a lot. They have created, you are familiar with the internet. China has created a quantum internet. They have satellites, which are quantum satellites, which are dealing with these things in terms of, as I said, quantum algorithms, quantum cryptography, etc., etc. And therefore, that has become a very, so it's something which is very interesting. It is very fundamental. So if you are the fundamental curious type, if you are seeking power, you are seeking applications, you are seeking to be very important in the world, quantum is the way to go. And point is very simple. Start learning it yourself. I did that demonstration the other day that I just asked Siri, hey Siri, what is quantum computing? And it gave the answer. And so on and so forth. So I wish you all the best. I think you will have a great contribution in shaping the future. I was just not telling you, earlier education was to get us ready for the world. Today, you are not going to be ready for the world, you are going to be ready to change the world. So, best wishes and thank you.